Okay. So I would like to explain this gate formulas for the analog subjective. So ripple factor. Ripple factor is it is a shortcut formula. So it will be helpful for at the time of examinations. Uh, at the time of examinations, so few days ago. Okay. So it is a revision purpose also very helpful. So analog formulas. The ripple factor equal to RMS value of AC component by DC component. So it is also written as the root over V RMS by VDC whole square minus 1. So RMS by RM average value is the nothing but the form factor. Form factor square root over form factor square minus 1. Okay. So it is mm, it will be form factor, peak factor, amplitude factor. So every factor is also formulas are necessary in GATE exam. Okay. So IC by IE. IC by IE is nothing but the alpha in CB configuration. IE equal to IB plus IC plus ICBO. So it is nothing but the collector to base leakage current. ICBO is nothing but the collector to base leakage current. Okay. So CB configuration. If CE configuration, so CE configuration IE equal to 1 plus beta IB plus 1 plus beta ICBO. So there are biasing techniques are biasing techniques in transistor are three types: self-biased, fixed bias, and collector to base bias. Okay. So collector to base bias. The diagrams are different. According to diagrams, so you can write the equations by using nodal analysis or loop analysis. Anyway, next one. So IE equal to 1 plus beta IB plus 1 plus beta ICBO. Okay, and biasing techniques also self bias, fixed bias, and collector to base bias. Next one. So comes to the next point. ID equal to ID equal to IDSS 1 minus VGS by VP whole square. So whole square. Here equal to means it is a relation between. So it is a relation between ID and IDSS into 1 minus VGS by VP whole square. If at all only hyphen, so there is a different point or so new point. Okay. So transconductance GMO. So transconductance equal to minus 2 IDSS by VP. So I implies means there is a relation between this point and this point. Okay. VGM equal to VGMO 1 minus VGS by VP. So next, overall upper cutoff frequency equal to F dash H equal to FH. So into root over 2 to the power of 1 minus N minus 1, where FH is the upper cutoff frequency of one amplifier. If at all N equal to 1, so there is a one amplifier. If at all two amplifiers, so there is a N equal to 2. And lower cutoff frequency, so overall lower cutoff frequency is the FL dash FL by root over 1 by N minus 1. Next, gain gain of the closed loop system equal to so equal to A by 1 plus A beta, where A is the open loop gain, beta is the feedback factor. Okay. Next is also FET. So VGO equal to minus VGM into VGS RD. VGS is the input voltage. Okay, VGS is the input voltage. Output by input equal to gain minus VGM into RD. VGM is the nothing but the del ID by del VGS. When VDS is the constant. Transconductance GM is nothing but the transconductance. Amplification factor mu equal to, so del VDS or VOS by del VGS. So ID equal to constant RD into GM. Effective GM equal to, so effective GM equal to GM1 plus GM2. IDSS is the maximum value of current when VGS equal to 0. When VGS equal to 0. Next, operational amplifier. Operational amplifier is the, so R2 by R1 equal to R4 by R3. So implies AC equal to 0. So AC is a common gain, gain of the amplifier. So CMRR equal to infinity. Vmax equal to slew rate by 2 pi ACL. ACL means closed loop gain. So VM. Next, integration is the output voltage equal to minus 1 by RC integration of V in dt plus VCO 0 plus. Differentiator equal to VO equal to minus RC dV in by dt. So logarithmic equal to A equal to, logarithmic A equal to V naught minus eta Vt ln. So ln V in by I naught R. Next, anti-log equal to V naught equal to minus I naught R anti-log V in by eta Vt. RC equal to, RC phase shift F equal to 1 by 2 pi RC root 6. Beta equal to minus 1 by 29. So Wien bridge oscillator frequency equal to 1 by 2 pi root over R3 R4 C1 C2. C1 C2. Next, Colbert oscillator frequency equal to F equal to 1 by 2 pi root over L into C equivalent. C equivalent is the series capacitor. So series capacitor equivalent capacity equal to, so C1 C2 by C1 plus C2. Clap oscillator F equal to 1 by 2 pi root over, so LC 1 by LC 1 by L into 1 by C1 plus 1 by C2 plus 1 by C3. So Hartley oscillator. So Hartley oscillator equal to F equal to 1 by 2 pi. So C into root over C into L equivalent. L equivalent is the nothing but the series inductances L1 plus L2. Next, output by input equal to gain. So 1 plus beta A. Beta equal to R2 by R1 plus R2. Closed loop system input resistance equal to 1 plus A beta R in input. Slew rate equal to E output by dt. F max equal to slew rate by 2 pi Vp. Vp is the peak voltage. CMRR common mode rejection ratio AD by AC. AD is the difference of the gain by C common gain. So next, relaxation oscillator T equal to 2 RC Ln. So 1 plus beta by 1 minus beta. So closed loop frequency equal to 1 plus A beta into F2. Zin equal to 1 by Gm. A equal to Gm RD. IC equal to alpha by 1 minus alpha IB plus ICBO 1 minus alpha. Alpha IE plus ICBO. Next, Arhanth handbook. So Arhanth handbook formulas. Beta equal to HFE IC by IB. Alpha equal to HFE S HFB IC by IE. ICO equal to 1 plus beta ICO. Reverse saturation current in CE. ICO less than ICBO less than ICO. So R equal to 1 plus Gamma is the nothing but the conduction angle. So 1 plus beta. TR rise time TR equal to 0.3735 by bandwidth. Next. So exam those two solutions ID equal to I S e power uh, e by eta vt minus 1. IB equal to IE by 1 plus beta. GM equal to dou ID by dou GS. VDS is a constant. Next, operational amplifier like this connection capacitor. So V01 equal to V in minus R1 by R1. Input resistance is also R1 and input resistance of the non-inverting mode also R1. So V plus equal to V in into 1 by J omega C by 1 R plus 1 by J omega C. Is nothing but the voltage division rule. V02 equal to V in 1 by 1 plus J omega RC into 1 plus R by R. V naught equal to V01 plus V02.